mean its beam efficiency is high. And the stable and zero side lobe performance is not a given as soon as you have a horn. But we do put a lot of effort into optimizing our antennas, and the results are clearly.
So this is interesting. He says that they put a lot of effort into optimizing their antennas for beam efficiency. And I believe that this is probably true. I think that they do believe their own nonsense about beam efficiency, and they probably do believe that most of the noise in WISP networks is picked up from the side lobes. And therefore, they design their antennas and they set the frequency range of their antennas based on the side lobe performance, the amount of side lobes. And so if they're designing an antenna and it works great in every other aspect, but it's got these side lobes coming out, then because of those side lobes, they're not going to use that design. They're not going to use the frequency range in which those side lobes manifest. Isohorns doesn't do that. We optimize our antennas, but we don't worry so much about the side lobes. So we have, in some of our antennas, we have prominent side lobes. And with those antennas, we still outperform RF elements every single time in real world conditions. And that's because all the other aspects of our antenna are solid, and the side lobes, while being prominent, that's not the problem. That's not necessarily the problem. The problem is, in fact, primarily the beam width when you're talking about picking up noise. Having some side lobes coming out doesn't necessarily destroy the performance of an antenna. Now, RF Elements seems to believe that the side lobes are the problem, and so they're not going to design an antenna that has prominent side lobes, even if the antenna otherwise performs well. So in this, I think that they're just buying into their own nonsense. And that is, in fact, despite them saying, well, that's one of the reasons why they build better antennas, it's actually a limiting factor in their antenna design, where they're trying to optimize for the wrong thing.
Similarly with the point-to-point antennas, the patch arrays are again at the bottom of the beam efficiency performance.
I just want to highlight here, they're beating up gyros for having low beam efficiency. Again, RF Elements beam efficiency is entirely subjective. They're not showing you the work, but they beat up ubiquity in the previous slide. They're beating up microtick and gyros here. This is not fair. So although I am critical of RF Elements, I try to always be fair. RF Elements was never fair in their criticism of their competitors. They were never shy about criticizing their competitors and beating up on their competitors, but they were also not fair about it. So keep that in mind when people criticize me for criticizing RF Elements. RF Elements criticizes their competitors plenty, but RF Elements always did so unfairly.
Due to the demanding frequency-dependent side lobes collecting and transmitting the noise, hurting any and every WISP networks, really. Now, dishes are somewhat better, and generally the bigger the dish, the better the beam efficiency becomes, and that's if the antenna is carefully designed and also well manufactured at the same time. What is interesting here is the Ultrahorn with its 99% beam efficiency. So only 1% short of perfection. If you ever wondered if Ultrahorn was worth the extra cash compared to a dish of equivalent gain, you have a very clear answer here. With 99%
of equivalent gain, that's not the measurement here. Like, you're not going to compare the Ultrahorn versus a 23, 24 dBi dish. It should be cost. So how much does the Ultrahorn cost? $700. What can you get in a dish for $700? Assuming that price is the constraint. Maybe wind load on the tower is the constraint, but then you would measure it versus equivalent wind load. But no, it's not gain. You're not going to measure the the Ultrahorn versus a 23 dBi dish. 23 dBi dish, by the way, is a light beam. So yeah, the Ultrahorn may outperform a light beam by a little bit, but no, you would put it up against an antenna at a similar price point typically. And with cyber antennas and isohorns, you can get a lot of dish for the cost of an Ultrahorn rather.
And beam efficiency, it will deliver high quality performance even in the worst noise conditions you can think of.
That depends on whether the noise is co-located noise or if the noise is coming from the area in the main lobe. And if the noise is coming from the main lobe, then the Ultrahorn is going to perform worse than a high gain dish.
The quality of antenna performance at both polarizations is also part of the overall throughput improvement. So let's see how. The traditional sector coverage is different when switching between the polarizations, which causes problems for the customers at the edges. Now, on top of that, because of the shape of the radiation pattern, the further away the customers are from the center of the sector, the worse their experience is. Where horn antennas, on the other hand, offer a uniform coverage in the whole sector and the same coverage area for both polarizations. So eventually every customer in the sector experiences the same high quality and stable service.
So again, this just reinforces what I'm saying. The advantage of the horn antenna is the narrow beam width. And with the narrow beam width, you get your stations closer to the center of the beam on average, where the signals are strongest and the polarities, the horizontal and the vertical chains, are most balanced. So this graphic shows the advantage of horns, but they're doing this is misleading. They're basically saying their antennas have more balanced horizontal and vertical beams. That's certainly true, but it's not for the reasons that they give. It's not just that their antennas are special, it's that they have narrower beam widths.
Now, anytime you swap a traditional sector for horn, you see an increase in throughput, and it's the throughput you can rely on and the performance it provides.
So I just want to stay on this for a little bit. If you had a wide beam width horn and you had an equivalent beam width sector panel, you're not necessarily going to get more balanced beams on the horn than the sector panel. But with this narrow horn, yeah, you're going to have more balanced beams within this narrow beam width. So it's not the horn or the sector necessarily that causes the chain imbalance. It's simply having stations towards the edge where you're going to see that chain imbalance. And when you bring them all towards the middle, then yeah, you don't have that same problem. And this is nonsense, by the way.
The trade-off between antenna gain and the SNR, or signal to noise ratio, is an important one to understand, especially for those who worry about the lower gain of horns compared to traditional sectors. With the patch array antenna sectors that are most common in the WISP industry, you get strong side lobes with the high gain they provide. Because of the ever-present noise, the performance you expect is diminished by higher, by as much depending on the height of the noise floor caused by the side lobes that decreases the SNR.
Again, most of the noise is picked up from the sector, not from the side lobes.
And this is because, again, the physics of these antennas. With patch arrays, you're at the mercy of the side lobes, and no matter the gain of the main lobe and how high it is, you are depending on the surrounding noise conditions caused by either you through self-interference of your own sectors, or even worse, through the interference which is spread by your competitors in the same area. With horns, you can easily see huge throughput increase despite their smaller gain compared to the old sector they replaced. How is that possible? Well, as is clear by now, the 5 GHz links suffer because of the background noise due to the side lobes of the antennas used.
So he keeps on saying the same thing. He keeps attributing it to side lobes. Again, you can see narrower beam widths.
Sectors have many side lobes. Now, if an antenna has no side lobes, which is the case with our horns, it doesn't collect the noise, which decreases the noise floor the radio is working with. And the radio cares mainly about the SNR, more than the signal strength alone, which is why an antenna with lower gain can provide better performance. The lack of side lobes lowers the noise floor, resulting into higher SNR, better MCS rates, and increased throughput as a result.
Again, no side lobes nonsense is just nonsense. It's the narrow beam widths that allow horns to perform better in noisy environments.
So let's now have a look at a few scenarios on how you can actually go about, or how you can see the effect of the horns once you decide to swap those old sectors for horn sectors. With the traditional sectors, your network throughput is very sensitive to its surroundings. So whether you or your competitors add new sectors, your network always sees it through the side lobes as decreased and unstable throughput. And the horn antennas, on the other hand, only cover and receive the signal from where they're supposed to and nowhere else. Because of that, this sector is stable and performs at the limit of the maximum radio throughput. Now, when increasing the number of subscribers in a sector covered by a traditional patch array antenna, you experience a decline of the throughput with every new subscription. Because the sector is wide and the antenna has strong side lobes, the colocation of multiple sectors is very difficult. With horns, you can divide the sectors into smaller or wider portions. And because of the lack of the side lobes, each of the collocated sectors performs with zero self-interference, superb stability, and throughput, which results into happy customer base and actually a headache-free network for you as the owner of the business.
So he just says that you can divide up a sector into smaller sectors, and that's true, but the reasons why he gives are misleading. So yes, it does make channel planning easier and sector division easier, the narrow beam width horns, but you still have to, as you scale up a network like that, you have to worry about co-location interference. And luckily for RF elements, most WISPs doing this used Rocket Prism AC with GPS sync and the Prism filter. And so they were able to scale up their networks and they were able to achieve frequency reuse, but not for the reasons that RF elements gave. And in fact, they did it despite RF elements' advice.
In a nutshell, dividing a wide and very sensitive sector into more compact units using horns with no side lobes, you can collocate as many sectors as you wish, while at the same time you can be sure that each of the sectors works at its best, leveraging the maximum throughput the radios enable. The patch-array sectors with their light side lobes always see the closely located sectors, resulting into you not being able to use the neighboring channels to leverage the full spectrum your radio supports. And due to the lack of side lobes, the horns do not see the neighboring sectors, which gives you the ability to fully reuse the previously noisy and unusable channels.
So notice there, that was the beam width. That wasn't the side lobes.
In the case, the neighboring sectors point away from yours. The side lobes are still strong enough to increase the noise floor your radio sees, which is resulting into lower throughput you can achieve. And horns can help here as well. I mean, not seeing the neighboring sectors, the noise floor is pushed down, the SNR is improved, and you can leverage those higher modulation rates up to the capabilities of the radios you use.
So side lobes would help in that situation. Reduced side lobes would help. But again, in that graphic, it was mostly the narrow beam width.
While the traditional sectors, with them, you don't have a lot of options in terms of the beam width. And the side lobes make addition of every new sector almost a cringing experience, because the network performance will gradually decrease with every additional sector. The superb colocation and lack of side lobes of horns, though, makes the growth of your network easy and pain-free. So you can grow the size of your network virtually indefinitely. And this is the core of scalability and the ability to grow your network throughput. Get the noise under control with horns, and adding new sectors becomes an extremely simple task. And here you see a few examples of how many horn sectors you can put on a single tower. Looks kind of almost unbelievable, doesn't it? With horns, though, this is daily reality.
Okay, I just want to point out, so yeah, they're stacking all these horns on top of each other. This is made possible not by horns and their no side lobes. This is made possible by GPS sync, and this is made possible by the prism filter. So RF Elements is essentially taking credit, misattributing, while talking nonsense about the actual technology that made this possible.
Control the amount of noise, everything else falls in place. And these are the pictures actually provided by our customers. They're not staged, they're real pictures our customers, I think these are from the United States, have provided us. So the RF Elements technology is the winning formula for unlicensed WISP networks. The lack of side lobes of horns ensures really great noise immunity. And the lack of coaxial cables and interconnects ensures delivery of maximum power to the antenna.
Okay, so their horn antennas have side lobes. Their twist ports have cables.
And the toolset of 11 different horn antennas with various beam widths and gains enable incredible scalability. So now you have.
So it's not having the options. It's not having 30 degree, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree horns that made scaling possible. It was the narrow beam width horns. So specifically, it was the 30-degree horns that made scaling unlicensed point-to-multipoint WISP networks possible. And RF Elements never really seemed to understand that.
Different tools that you can really use to optimize the coverage of your network as you please. So you, on the other hand, have the spare time to focus on the growth of your company instead of having to run around and keep servicing the underperforming links and taking the calls from complaining customers all the time. And all these benefits,
Okay, again, so they just showed towers with horns stacked on top of each other, and here they're saying you don't need GPS sync. You don't need to spend the extra cost for fancy radios. You can increase throughput with horns using any radio, microtick radios. You can do it with microtick radios. And it's cost effective using their special horns. It's just not true.
At no added cost, really. You can easily do without GPS sync if the antennas do not see each other like horns. And due to noise suppression, you do not need to use the wide channel.
So you don't have to take my word for it. You can take any of your horns co-located on the same tower, and you can do a scan from one of the APs, and you'll be able to see the neighboring APs, and you'll be able to see the signal levels that AP sees the other AP at. That's with two APs pointed in different directions. You'll still see strongly the signals of the other APs. And so you still have to contend for the channels. You still have to contend for carrier access if you're operating on the same channel. But if you're using GPS sync, then you can get away with operating on the same channel. If you're using radios with the prism filter technology, then you can filter out noise that's out of channel. RF Elements tells you you don't need that you can use just their magical horns with no side lobes, and then you don't have to deal with it. This was easy for anyone to disprove, and yet somehow they were able to get away with this until Isohorn started talking about it. So until I started criticizing RF Elements, you won't find criticisms of RF Elements. You won't find anybody calling out this nonsense. That's because RF Elements built up a cult and told WISPs obvious lies. And essentially being a member of their cult meant that you would give up your reasoning power to show allegiance to the cult. And this went on for years, basically until Isohorn started fighting back against the nonsense and against the cult.
Or spend additional money for non-effective fixes. Horns are a complete solution in and of itself. So this concludes the main the main topic of this presentation.
All right, well, that'll do it for me. Thank you.